Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ugwabela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 and we are still on Newton's second law. It says a crate with a mass of 25 kg slides down a plane which is inclined at 15 degrees to the horizontal. During the first part of the motion from A to B, there is no friction. So note that from A to B, no friction. And then, but part BC has a rough surface. So if part BC has a rough surface, that means there is friction here. So friction is present here. Now 5.1, they say draw a free body diagram of all the forces acting on the crate while it moves from B to C. So at this part here where there is friction. So to ensure that we draw everything properly, let's just start with the incline like that. And then let's include our forces. So you always know that I prefer the one that is resolved when it comes to drawing, because I always tell you that this one helps you a lot when it comes to calculations, because you can see all the forces and components there acting either horizontally or vertical. So with calculations, you want to work with forces that are either vertical or horizontal. So no diagonal forces. Then you have it like that. Up there, we have our kinetic frictional force. So how do they mark this one? This is 3 marks, guys. So remember, this is normal force. This will be marked as 1 because they are components of the gravitational force. So they represent 1 force. And then this is another mark. So be careful with this one. If you include the FG perpendicular, but then you forget to show your FG parallel, that means you'll forfeit a mark. Because where there is FG perpendicular, we also need to see FG parallel. So they always go hand in hand. But then if you prefer to just draw the one that is not resolved, no problem with that. You just have to always remind yourself that the forces that you'd have to show there on your F net are these ones, the FG parallel and FG perpendicular. So always note that. So with this one, you always have to remind yourself that this can be resolved into components. So it can be a bit tricky to calculate with this one here, because you don't see all the horizontal and vertical forces acting on that object. Okay, but then either way, also this one could have got you 3 marks, 1, 2, 3, right? So either this or that. The memo gives the option for both. So do not feel left out if you drew this one or you drew the other one. Both of them are correct, guys. Then 5.2 says calculate the magnitude of the acceleration of the crate while it moves from A to B, So note this. They've now shifted from B to C. They now want us to calculate from A to B. Note that from A to B, if we are to draw a free body diagram from A to B, you do understand that there is no friction there. So we would have it just looking like this, the normal force, and then our FG parallel, and then FG perpendicular, then our FG parallel here, sliding down the incline. Right. So you can see that the only horizontal force that will be acting here is the FG parallel. So that means the net force will be composed of the FG parallel only. Remember, these ones, we won't include them because we know after all they will just cancel. If your object is just moving like this here, that means we do not consider these vertical forces. Right. So that means calculating this, we have F net is equals to M times A, but our F net is only comprised of the FG parallel, or only comprises of the FG parallel. So we have mg sine theta and then m times a. Now we can just substitute our mass is 25, and then we have 9.8 sine 15 degrees is equals to 25a. Now at this point, we can just divide both sides by 25, and then we will have our value for a. So 25, can just punch 9.8 sine 15. Then our acceleration will be 2.54 meter per second square, right? So that's the magnitude of the acceleration. right? That's the magnitude of the acceleration while this object is moving from A to B, right? So now we do understand when it now enters part B to C, it obviously has to slow down because now here there is friction. Okay, so that's what they're asking in 5.3. They are saying write down the direction of the acceleration of the crate while it slows down from B to C, right? Only up the slope or down the slope. Remember, if something is slowing down, that means we have a deceleration. So it's no longer acceleration, it's deceleration, which we, in grade 10, we used to call this the negative acceleration, right? So this is the acceleration that you get when you apply the brakes, for example. So if it's in a car, you apply the brakes here, but then in a form of the crate there, that means the crate is slowing down. So deceleration involves slowing down. So remember, even if you're applying the brakes, you are slowing down until you come to a stop. So here we know that deceleration is always in the opposite direction of motion. So deceleration is always in the opposite direction of motion, right? So the motion of this crate was down the slope. So that means our acceleration, if it's slowing down, needs to be up the slope, because remember, deceleration is always in the opposite direction of motion, right? So the correct answer there is supposed to be up the slope. Okay, then let's move to 5.4. It says calculate the magnitude of the net, it's telling us the magnitude of the net acceleration from B to C is 1.2 meter per second square. Now calculate the magnitude of the frictional force acting on the crate, right? So now it's from B to C. That means we will make use of the free body diagram that we drew in 5.1, which is we had the normal force here, and then we had the FG perpendicular, then sliding down the incline was the FG parallel, then opposing the motion was the kinetic frictional force, right? So now having to use this, we are supposed to calculate the magnitude of that same kinetic frictional force, and then we are being told of the acceleration here. So we know that we are supposed to apply the formula F net is equals to ma. So note we are solving 5.4. And then this becomes the positive direction, because remember the direction of motion of the object is down the slope. But then up the slope, that becomes the negative direction. So how are we supposed to then write this? Supposed to say the positive direction minus the force in the negative direction. And then we have ma. Breaking this down, we know that FG parallel always becomes mg sine theta. So that means we will have the mass is 25 and g is 9.8, then sine 15 degrees. We are looking for Fk. So let's just write Fk there. Then this is 15. So our mass still 25, but then we are given the acceleration is 1.2, right? Now at this point, note here, the acceleration is 1.2, but then since we are told that this acceleration is actually a deceleration, there's something that we need to do with this acceleration. We must indicate it as a negative, right? So that means we have negative 1.2, because this acceleration is now acting in the opposite direction of motion. It is causing the crate to slow down. Right. So because the acceleration is in the negative direction, negative acceleration, we need to indicate it as a negative here. Remember, deceleration is negative acceleration. Then, okay, when punching this into our calculator, we now have 63.41 minus Fk. Then multiplying this will give us 30. If we take the Fk over to this side, we have 63.41. And then this is negative 30 meant to say. So we are supposed to have negative 30 there. If we take the negative 30 over to this side, that's plus 30, and then is equals to positive Fk. So adding this 163.41 plus 30, this should give us a 93.41 newtons, right? So, okay, that's how you were supposed to tackle this question there, all for a total of 12 marks. So please press the thumbs up button if you have enjoyed the lesson and then you have also found it helpful. And also, if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.